Welcome to Fantastic Solutions. So today we'll be solving one more lead code medium problem, which is unique paths 2. And the similar problem in the previous one, we solved unique paths, and this is just enhancement of on top of that. And this is again into the dynamic programming. So let's try to read the problem and see how we can solve this. And we'll see both previous and the current solution as well. So this says you're given an m cross n integer array of grid. So we have a grid of integer array, and there is a robot initially located at the 0, 0 location. Instead, the robots try to move to the bottom corner, which is this place m minus 1, n minus 1. And we can let us see the conditions. What is the condition we have? So condition says the robot can only move either down or to the right at any point in time. So let's say if robot is at the start point, it can go right or down. Just assume if robot is at this place, robot can move right or down. This left and top, these are invalid moves, like these are not allowed. The next thing is an obstacle and species are marked 1, 0 respectively. So in input grid, if 1 is basically means the obstacle here, a path that robot can cannot include any square that is an obstacle. So a robot cannot include this obstacle path in those paths. So now we need to return the number of possible unique paths that the robot can take to reach the bottom right corner. So if we see, the problem is exactly same, what we have the previous one, only enhancement or only one extra condition we have. We got an obstacle, added in this particular grid, and we don't have to consider that path. So let us see if there was not any, the obstacle here. So how many ways robot can reach from start to end? So like one of the path could be this one. Second can be like this one. Third could be this one. And fourth could be this one. Can have fifth, this one, right? And similarly six, this one. So around 6 paths we can have. But now due to this obstacle, a robot can take this path, this path. So these are the two valid paths. Any other to get any other path, the robot has to come to this section, which is not allowed. So that's why answer is 2. So let us see how did we solve the previous question, and can we use that one only. So this was 3, 7, this grid, and let us see how did we solve this. So this was our start position here. So for that, this was our start position. And what have we done? I would recommend to go to and see this solution as well, but I will quickly summarize so that we can try to solve this one. So our goal was to find for each cell, in each cell we're putting some numbers, and the numbers always say like how many ways we can reach to that particular cell. So to come from start point to this cell, we have only one way, right? Robot can come only this way. Similarly, to go down, there is only one way. To come to this cell, robot has only one way, like it can go right. And to come again to this cell, it has only one way, right? This one. Let's say to come this path, can robot take this path? Right, down, right? Can it take up? No. So this up is not allowed, that extra path, which came. This one is not allowed. So that's why we know, like in the very first row, to go to any point, right, till the end, robot has only one way, like only one option. So that's why what we did in that solution, for each row we initialize, for the very first row, we have initialized the number of ways to go to that particular cell is only one. That's what we did. And the same thing gets applied to the first column as well. To come from start to this particular grid, we have only one way, which is down. And to come from this to like this one, we have only one way, which is down, right? That was the only option. So that's the only thing which we did for both first row and first column. We initialize with one because that many ways we can have it. The main things comes when the rows gets different from the first. So to come to this particular cell, robot can take this path and this path. So there are only two paths, right? So if we observe this, these two paths are coming nothing but the sum of the previous, these two paths. So 1 plus 1 basically came as a 2. Quickly, if we try to see for this path, so robot can take this path 1, 2, and 3. These three paths robot can take. And again, if you see, this is the sum of these two previous numbers. So previous row and sorry, previous column and previous row. That's the sum it's coming. So if you see at the end, if I and j were not 0, what we did, we initialized the each cell with previous row and previous column values, sum of those two things. And at the end of the day, now we know, let's say when we come here, so this will have the 21, this will have 7 ways. So 21 plus 7 is nothing but 28. So the final answer is always into this m minus 1 comma n minus 1. So we just return, this m minus 1 comma n minus 1. That was the approach for this unique path. Now for the second approach, we have one extra thing, which is basically we can have obstacle at any place, right? So obstacle, like what were the three things like which we did? Each row, like first row, first column initialize, and then for none first and none column, three operation we have just did, right? So let's try to put obstacle into the first row. Let's just assume this one, this place, and this place, and any none first row, none first column, let's just say this one, okay? So if you see, the numbers basically says that 1, 2, or 3 or 0, like that basically tells us that to come to this cell, how many path the robot can take. That's the only thing it tells. But now in our current question, it says one basically means an obstacle. So we need to, if you're going to use the similar solution, we need to alter our input, which basically means let's change our this ones to something else, some numbers or some, sorry, not numbers, some character or something else. So that is the very first thing which we need to do, so that we can just follow the previous approach to solve this. So for the timing, let's assume we are making as a crossed for obstacle instead of one, and other places like would have in our input array 0 and cross. So the very first thing we'll be doing will be initializing each of our the cells with either 0 or x. Now let's see the three approaches for the first row, first column, and the other thing. What all can we do? So if we see let's say if this was an obstacle, so if we see try to observe these two cells, so can robot come here? So yes, definitely robot can come, and it can take only one path, right? So we can initialize these two places with one, right, which is correct thing. So these two places will be one. Now, the moment we see that this is an X, right, we don't have to do anything here. So in the first row, the moment we find that we have an X, we can just leave it is as it is, right? We don't need to change it. But what about the other cell after this, X? Can robot come here? So if you try to see here, now the path on the right side is block. Robot can take right, can take right after down, and then can it go up? No. So this is invalid case. So we know that now robot cannot come here as well on any next path into the first row. So what we also need to do, so the first thing we need to do, like initialize the numbers in first row with 1, and before that, like mark all 1 with cross. So that is basically blocker. And then we need to initialize the first row with 1, the valid cells. The second thing we need to initialize non-valid cell with again X or cross, because those are again blocker for us. So we need to initialize them with again X because robot cannot go here. And the same condition will go for the first column. So robot, let's say, cannot come to this particular case. So we, instead of having 0 there, because in our input array will contain 0 here, we need to go and mark it as X. So that's the very first thing we need to do for these particular cells. Got it? Now, what about the none first row and first column? So what we'll be doing? So let's say if there is no, blocker or no obstacle, right? So let's say if you're trying to find how many ways robot can come to this cell. So the same approach we can apply. Previous column and previous rows sum, we can do that and we can get the answer. So here it will be 6. But what about this place? So to come to this place, robot can either come from here or it can come from here, right? So to come from here, it has 15 ways, but can it come from top? No, there is no way it can come from top. So that's why the total number of ways would be 15 only. So what do we mean by that? So to the blocker, let's say if you're initializing with X, so 15, the moment we are going to add it, right, this part, if any of the numbers are basically X or blocker, so just change it to 0, and then whatever the number is coming, we can do it. If there is no X, then yeah, whatever the number were there, like the previous thing, we have to do that. And then finally we can just return this m minus 1 comma n minus 1. If you do these things, so we are able to solve it. Let's quickly see. So to save the time, I have already written the program because I know like the video would take time, so I just wrote the program and explained this properly. So explanation was much more important, and we can just go through program how we have written and see the explanation as well. So this is basically an edge case. We can just ignore this. I will talk about this in last. The very first thing what we did, for each number, we are just going through the grid and checking if it is 1, right? So we are changing into the grid as a X. So the very first thing which we have to do, like, because 1 basically shows, in our problem that 1 basically means the obstacle. So what we did for all the obstacle, we are just updating with the X. So that's what, this part is doing. If obstacle of I comma j equals to 1, then mark the obstacle grid of I comma j with X. So now how our grid will look like? So our grid should look like 0, 0, 0, x. So here it will look like, the second one, we are just going to update it. All places will be as it is. So if you see here, it will have, 0, x, 0. And these two will remain as it is. So that's what, this is doing. And once we have it, because now we know the obstacle, so then again, we just need to follow the previous solution, right? This one, the very first row and first column, and then try to sum it. So in first column, if you see, we had 3 scenarios. One was till the place, initialize the values with 1, where we haven't encountered, this cross mark or X. So that is the one. Second, after this X, initialize everything with X, and wherever we have X or cross mark, leave it. So these are the only 3 operations we have to do it, right? So now let's try to, iterate our loop again and see what we can do it. So if you see, we're starting grid again, I equals to obstacle grid dot length, j is equals to less than obstacle grid of I dot length. And now you're saying if you're on the very first row, I equals to 0, right? So you're trying to fill this one. If I equals to 0 and I is an obstacle of grid I comma j not equals to x, that means if you enter the first row and the current cell is not an obstacle, right? So we're just ignoring this part. So this is what this condition says all about. So this condition, if you say, so this obstacle, like we are into the first row and the current cell is not X, right? So this is basically like we are just ignoring this. So this part we have taken care of this part. The second thing, what we are going to do, how can we know that we have to mark X here and 1 here? So to mark X here, if we see, if I have an obstacle here, let's quickly, try to clean most of the things. So we have an obstacle here. I can just move this. So we had an obstacle here and we had an obstacle here. So how do I know I have to mark X here? So if you see, let's say if you're coming to this particular cell, right? Our pointer is coming to the cell. So we just need to look to our previous cell, whether it contains an obstacle, like whether it has been marked as an X. If yes, then mark the current cell with X. Similarly, then we can move to the next cell and again we'll see whether it has mark with X. If yes, then again mark with X. So this one we have taken with one condition, and this one we'll just need to see all the previous condition, whether they are marked with X or not, and then update them to X. So then, we can take care of this part. So you see this one has been, so here what we're saying in the first row and it's not X, and as well as if the J is greater than 0, that means we are into the second column onward, and then we're checking in obstacle grid of 0 comma j minus 1, like in the very first row, j 0 comma j minus 1, that means when we are here, we are checking the previous values, the previous cell value. So if it is x, if if it is not equals to x, right? So let's, if it is not equals to x, let's read first this condition, then that will be clear. So this, that is the same condition. If I is equals to 0 and grid is not equals to x and j equals to 0 and 0 minus 1 is equals to x, right? Then we are marking our current cell with x. So that's what we did here. So all the cells we have just updated with the x. The moment we see the previous value is equals to x. Else if, so this is if, either else if. So now we can see the top one. That is a exact opposite condition of this. So this one will be same. I equals to 0, obstacle grid of I comma j not equals to x. That means we are ignoring this part. And in the second half, if we are into the more than, like we are not into this 0th column, so we are checking it column is more than 1, then does obstacle of grid j minus 1 the previous cell, if it is not x, right? Say if I'm here, right, and the previous column is not marked as x, that means I have to update that with 1. So these are the three things we just did it. So we have also completed this part, and we have left this as it is. So this is the that if block basically for the first row. And if you see the same if block we have the for the first column for this block. So now if you say I has been replaced with j equals to 0 and obstacle of grid not equals to x, and I is greater than 0 here, and obstacle of grid I minus 1, that is the previous row. Previous row is, if you're here, then previous row, if this is not x, then we can update with 1. Otherwise, we'll have to update with x. So that's what, we have just done it. So these two things are nothing but, if you see in the previous question, that is the same thing. So we are directly updating with 1. Here we are just checking whether we have to update with 1 or x. So that's what we just did. Now the remaining part, the third part, if its I is not equals to 0 and j is not equals to 0, then just update the current cell with the previous cell values, like some of those previous cell values. So now let's coming to this point. So this condition again says if I equals not equals to 0 and j not equals to 0, as well as the current cell doesn't have x, right? Because if it doesn't have any, what do we say, obstacle. If it has obstacle, then there is no point to go ahead and update with some value, right? So that's what we are just taking care of that. And if you see, now we are going to update our current obstacle grid I comma j with some values here plus some value here. That's what we are doing. And the previous solution also we did the previous row and previous column. And if you see, we are doing the same thing. Some values here and then plus some values there. And what is this value? So if you see the values are same, it's obstacle grid of I comma j minus 1. That means the previous column. And I will explain this condition is what. And then plus obstacle grid of I minus 1 comma j. So previous column and previous row value we are adding, but we're just taking care this extra part which we are talking, right? If it's a number, like both of them are number, then just go ahead and add them. So that's why we'll be getting 6 ways here. But what if one of them is not number? So we'll have 15 plus x. So x we have to replace with 0 and then provide the number of ways is 15, right? So that's what we are doing here. So we have obstacle grid of I comma j minus 1. If it's marked with x, then replace with 0. Otherwise, whatever the number we have it, keep it. Then plus similarly obstacle of previous row value. If it is x, then replace with 0. Otherwise, keep the original value. And then our each grid cell value will be updated. And now once this is ending, like all the for loop has ended, we just need to return the obstacle grid of m minus 1 comma n minus 1. And here again, we're just keeping an extra check whether if this is an x, then just return 0. Otherwise, we know that final solution will be m minus 1 comma n minus 1. So that's all about this program. And then on top, we had some edge cases. Let's see those edge cases as well. So very first edge case, it says if obstacle grid of 0 comma 0 is equals to 1, then just return 1. Sorry, return 0. Because if the very first cell we have marked with 1, right? If there is some input scenario, because if the start point is already 1, like we cannot, if this is an obstacle itself, then we cannot move forward, right? So just return 0. There is no point in doing calculation. The second thing it says, if m equals to 1 and n equals to 1. So what do we mean by that? this place. So if m and n equals to 1, an obstacle of grid 0 comma 0 not equal to 1. So like if it's a m is basically so grid of length of grid, right? So if it's a 2 cross 2 grid, so if it's a 2 cross 2 grid, and here we are saying if this particular block is directly 1, so if this is 1, we have updated it 1, right? Now, so this is 1 before all the conditions. So 1 basically means if m equals to 1 and n equals to 1, if that means basically we have a 2 cross 2 grid. And then if the current obstacle is not equals to 1, because so that means here we don't have any obstacle at all, right? In that scenario, just return 1 because there is no, we know that there is only one way to, move to that place. Hold a second, we'll just see. No, no, no. So this is not 2 cross 2. This is 1 by 1, right? So 1 cross. So this one. So this will be a normal cell. So this cell, if that is the cell, and if it's a 0, then we can directly return 1 because there is only one way. This is the start and end position as well. So that was this condition. And then we know like we have done all the solution which we just talked about. So yeah, that's all about this program.